All right, today, lesson 25A, graphing inequalities. So today you will, last year you were supposed to graph inequalities, and what I'm finding out is that some did and some did not. But today our objective is to graph inequalities. We are also going to state inequalities verbally, write inequalities from word phrases, and then the main reason why we're learning this is because when we solve inequalities, we have to graph our solutions in addition to solving this. All right, so a little vocabulary. An inequality is a mathematical sentence that contains either a less than symbol, a greater than, a less than or equal to, greater than or equal to, or sometimes even a not equal to symbol. So, this symbol, in case you have forgotten, it's in the table. That's referred to as is less than. This symbol means is greater than. This symbol means is greater than or equal, or is less than or equal to. This symbol means is greater than or equal to, and this symbol means is not equal to. Now, that's not the only things or only phrases that will lead to those symbols. There are other phrases that also lead to those symbols, and most people don't have any problems if it's phrased that way. But if it's phrased slightly differently, some people have trouble translating that to an inequality. So that's what this table all represents here. So you have some things you need to fill in here. So is less than, here are some other common word phrases that mean is less than, like fewer than, or like below. So once again, you need to be filling these in. Greater than has some other word phrases that represent the same thing. More than, or above. Other word phrases for is less than or equal to might be at most, or no more than. Other word phrases for is greater than or equal to, at least, or possibly no less than. So these other phrases, word phrases, these are common word phrases that also represent inequalities. All right, so to rephrase everything that I just mentioned as far as the word phrases, is less than also is fewer than means is less than or represents the same thing. Is below represents the same thing. Is more than means the same thing as is greater than. Is above means the same thing as is greater than. Is at most represents the same thing as is less than or equal to. Same thing with is no more than. Is at least means the same thing as is greater than or equal to. Same with is no less than. They are equivalent to each other. They mean exactly the same thing. All right. Here we have a whole bunch of inequalities, and I need you to write this down. In your notes, you have a little phrase that says examples, and then it's blank underneath of that. I'd like you to copy these down. And then here's what I'm going to have you do. I'm going to have you turn to your shoulder partner, and you're going to trade off, and I want you to say these in more than one way. So for example, right now, you have 3 ways of saying something that means is less than, right? Is less than is one. What's another way of stating is less than?
Fewer than.
Okay, or what's a third way? So you have 3 ways. I'm only asking you to phrase them 2 ways that represent the same thing. Everybody clear on what I want you to do?
Yes.
This should only take maybe a minute to a minute and a half. So turn to your shoulder partner and make sure you use correct vocabulary. So one way of stating the first one would be 5 is less than 7. What would be another way of saying that?
5 below 7.
5 is below 7. Okay, that'll work. I'm going to take the easy one on this one. It's x is greater than negative 12. What would be another way of saying that? Yes.
X is more than negative 12.
Good. X is more than negative 12. I'll take the easy one on the next one. C is less than or equal to 3. What would be another way of saying that?
C is at most, then, wait, C is at most equal to,
No, just at most.
at
But-
most, then
2. Did you say C or 6?
6.
Oh, okay, there we go. So 6 is greater than or equal to. I think you were getting both those two things mixed up, right? I had read C is less than or equal to 3, and then you are mixing the two together. So at most. So I'm going to take the easy one on this one. This is the one we're on now. 6 is greater than or equal to 2. What's another way of stating that? Animal?
6 is at least 2.
6 is at least 2. All right, good. And then there really is only one way of saying the last one. Negative 8 is not equal to negative 1. So there are many ways of saying phrases that represent inequalities. All right, next thing. This inequality says x is less than or equal to 2. Here's what I want you to do. I want you to think of some solutions to this inequality. Here's what that means. Think of some numbers that you can put in for or substitute for the letter x that will create a true statement. Right now I want you to think of that in your head. Turn to your shoulder partner and each of you come up with 3 numbers that if you substitute them for x, it will make a true statement. I'm going to give you about 30 seconds. Go. All right, give me one number that will make a true statement.
Wait, can I use the median?
I just want you to give me one number that will make a true statement.
Negative 1 billion.
Negative 1 billion. I like that one. Give me another one.
X equals 6.
So 2? Using 2 for x? Yeah, 2 is less than or equal to 2.
Negative 1.
Negative 1. One more.
0.
0. So those are all numbers. But I have another question for you, and that is this. How many solutions do you think that there are? Quickly turn to your shoulder partner and discuss that for a second. How many do you think there are? In math, when there are an unlimited number of solutions, we say that there are an infinite number of solutions. Because there are an infinite number of numbers that are less than or equal to 2. You know, Michael gave us negative 1 billion. That's way, way down the road. I heard 0 and negative 1 and 2. But there are an infinite number of numbers that you could put in for the letter x and make a true statement. Okay? All right. So how can we graphically show that? Well, the first thing we need to do is we need to draw a number line. And I think you already have the number line there. But let's go ahead and quickly input those numbers on our number line. And I'm going to stop for a minute to let you get caught up on that. Okay, so if we wanted to graphically show x is less than or equal to 2, we're talking about all the numbers on that number line that are less than or equal to 2. For example, 1 is less than or equal to 2, and 0 is less than or equal to 2, and 2 is less than or equal to 2, and negative 1, negative 2, negative 3, negative 4, those are all less than or equal to negative 2. But we also can't forget about numbers that are in between numbers. That's about 1.5. 1.5 is less than or equal to 2. So we're also including decimals and fractions, not just integers. And so if we wanted to piece all of that together, it would basically be all of those numbers that are lower than 2, but also equal to 2. So here's what I want you to do. Make a solid dot above 2 and have an arrow going to the left. Because what this is representing is it is representing all of the numbers that are less than or equal to 2. And of course there's an arrow there because we can continue on to negative 1 billion, negative 1 trillion, and so on. All right, so this graph represents all the solutions to the inequality. It's a quick, easy way of showing all the numbers that would make a true statement. All right, here's our next one. X is greater than negative 3. Let's create another number line just like the first one. X is greater than negative 3. Could somebody give me a number that we could put in for x that will make a true statement? Yes.
Negative are just keep on going to positives.
Say that again?
Infinite
Okay, but I just want a few numbers that will make a true statement. Let's try and get some numbers that are actually show up on our number line here, because a billion would be way, way, way to our right there. 3. 3 is right there. 1. 0.75, which would be about right there. So basically, there are lots of numbers in here, all of these numbers in here, but this time it's x is greater than -3. So that means we don't include -3. So in a situation like that, we're supposed to use an open circle because it's all the way up to 3, but not, or excuse me, -3, but not including -3. And that's how you determine the difference between an open circle and a closed circle. If we don't include the number, it's open. If we do include it, it is open. So, all of these numbers in here make a true statement to that inequality all the way up to -3, but not including -3. So that's what our graph should look like. So to summarize this, anytime we are asked to graph an inequality with a less than symbol or a greater than symbol, and we are now on the back side, we use an open circle because we're not including the number. And if we have a less than or equal to or greater than symbol within our inequality, we close in the circle because that means that we also need to include that number. Okay? So for example, if I asked you to graph x is less than or equal to -1, and this will be the first problem where we don't have to draw all those numbers. There's no point in us drawing all of the numbers. So let's just draw a number line. And the only numbers that you have to have on your number line from here on out are 0 and then whatever number that we're talking about, which we're comparing that to -1. And -1, of course, is on the left-hand side of 0. And so we have to decide, are we going to put an open circle or a closed circle above -1? Which one? Just say it. Closed, because we're including -1. Now remember, we're talking about all the numbers that are less than or equal to -1. And this is why I was asking those questions earlier. All the numbers that are less than or equal to -1 are all on this side. Like -2 and -3 and -4 and -1 billion. All on that side. So that's how we determine which direction that we draw the arrow. So that's what the graph for the first example should look like. Here's another example. X is greater than 4. We draw our number line. We have to have 0 on there and we have to have 4 on there. And it doesn't matter to me how big the gap is there. Are we going to use an open or closed circle? Open. And it needs to go above 4 because we're comparing it to 4. Now, are the numbers that are greater than 4 on the left of 4 or to the right of 4? To the right. So that tells us which direction that arrow has to go. All right, so here we have some sentences. We're first of all going to turn these into an inequality, and then we're going to graph it. So I want you to look. You may have to refer back to the other side of your notes to figure out what that's going to look like. But first, we're going to come up with the inequality. Let's do that first. Going to be, what's it going to be?
X is less than or equal to 3.
Very good. X is less than or equal to 3. That's what x is at most 3 looks like. If you don't believe me, look back in that chart where I had you copy down those other phrases. All right, now graph it. Let's take a look at this one. We have less than or equal to. That means we need to include the number. We're including the 3. Therefore, it is an open circle over 3. Or excuse me, closed circle over 3. And an arrow to the left because it's all the numbers that are less than or equal to 3. I would like you to now do number 4 and number 5. First of all, come up with the inequality that you're going to use, and then draw your number line and graph. Number 4, a number x is above -2 The inequality that represents that is x is greater than negative 2. That's what I saw most of you have. The graph of that is not including negative 2, so therefore an open circle above it. All the numbers that are greater than or larger than negative 2 are to the right, so that's why our arrow needs to be going in that direction. That graph represents all the solutions to that inequality. Number 5, a number x is fewer than negative 4. X is less than negative 4 is the inequality that is represented by that word phrase. We are not including negative 4, therefore open circle above negative 4, and all the numbers that are smaller than negative 4 or less than are to the left, therefore the graph is, or the arrow is drawn to the left. All right, we finished this lesson off with a graph, and you have to come up with the inequality. So you have all these graphs in your notes. I'm going to do number 6 with you just to make sure we're doing the right thing. Well, let me give it to you. Anybody have any idea what that inequality would be? That graph would be the result of that?
X less than 2.
X is less than 2. Very good. That's what I'm asking you to do. Okay, go ahead and quickly finish 7, 8, 9, 10, and 11. All right, number 7. The inequality is x is greater than or equal to negative 1. For number 8, the inequality is x is greater than 0. For number 9, the inequality is x is greater than negative 9. For number 10, the inequality is x is greater than or equal to 15. And for number 11, the inequality is x is less than or equal to negative 24. Any questions? All right, quickly turn to your shoulder partner. Regarding the objectives today, the ones start the conversation. What did you learn today?